the value options. So let's say that one. Let's have a little look at a sketch of this function without any absolute value to work on it. What would that look like? It's quadratic, yeah. Yeah, it's a U shape, yeah. It definitely goes through 0, 0, is it?
Yeah.
Goes through here. Any other route? 2, yeah. U shape then. Something like that. Perfect. That's what it looks like. Now, what would happen if I were to graph
that middle number was the over the x-axis.
it could be more. Done this before?
Yeah.
But it makes sense that
yeah.
the bit that would be this bit in the middle would be then reflective because it's
Negative.
anything negative would become the exact opposite. So yes. So in black is it would follow the same route and then we kind of bounce off the, for want of a better term, the x-axis. What happens if it's y is equal to f and the absolute value is in the brackets? Flip it. Why? Flip it what direction and how much? And
So just everything doesn't work. It's like, I guess it'd be a normal parabola, but it was a little strange because anything over the side of the y-axis can't work.
anything over this side won't
Yeah,
work.
that's like.
So you can remove that.
Yeah, but it's absolute value, so those values would be the other way.
So when you get all of these,
It'd be like another, like,
Could you get a negative answer out of this? Could you get a negative y?
no.
Oh yes, no, maybe. Well, let's find a point where it could be. So if only so this one, whatever that churned out, turned positive. So what it was churning out was all the y values, and it would turn positive if it was negative. This one's slightly different. This one is, you're substituting in only positive values of x into this, but not necessarily only getting out positive values. So I can come up
Put in
with,
0.
yeah, put in 0. 3 times 0.
Oh, wait.
0 is, or positive, yeah, you can put in that.
Put in 1.
Yeah, if you want to put in -1. -1 work as well?
It would.
Well, let's put in -1. So -1 modulus.
I think you said x equals 0 to find the y.
I don't need, well, I could. I'm just testing for you.
Not -1. -1 is get negative times negative, you get positive.
Well, no, you won't. It's just going to be 3 times 1 then. The absolute value of -1 is 1. Isn't it?
Oh, yes, right.
Yeah. First of all, what is absolute value? It is its distance from 0. So, yeah, it's like, if you want to talk about in absolute terms, why would you ever need this? Absolute terms, the value of negative money is still negative $1,000. It still has a value of $1,000. So the absolute value. Anyway, so that would just be 1 minus 2, and that's a negative. Okay, so that gives -6. So we can get a negative 3. 1 minus 2 is -2. Okay, so we do get a negative value. So we can get negative y values. That means we can go down here.
I thought you just said the absolute value of the function will only be positive.
The difference between these two now we're doing the diagram.
Oh.
This one,
Yeah, that's the entire function.
if I got -3 out, I would change it to +3. This one is only the x that's positive, so we need to figure out what that's going to look like. Not entirely sure.
It's like the normal parabola, but not that something goes up.
Let's just draw the normal one again. Have a sketch of it. Have a sketch. What do you think that looks like? Our normal one went through 0 and 2. We were happy with that, and it was a U shape. What would happen if the x can't be negative? Tired of what happened if you still did negative values.
Just gives you the line that you already have.
So remember, when we subbed in -1, we got -3.
Yeah.
So that's going to have to be a point on this new one. So -1 was here before.
Oh,
So the previous, if we didn't have to do all this jazz with -1, what would we get? That would be -3 then in the bracket here, wouldn't it? If it was an absolute value. -3 times that, and that would get positive. That's on its way to glory. This one is down here somewhere. It's like maybe at -1. Let's just say it's here-ish. You reflect this with the x-axis. So it goes like, so it was down, so it pops down like that. Could. Let's just try another negative number. Let's just do -10, because we know that's going to be, is Dustin right? And it goes all the way down there and just continues to infinity. Let's put in -10. So 3 bracket -10, which turns to +10 times 8. So that's going to be +10. So that's 3 times 10 times 8. That's back positive. That's way up here. So it goes up again. Yeah, after. So, but where what does it look like? Where's the turn?
well, after that.
This is 2. Here is -2. Comes back to here. And then it flies off. What's it a reflection in? In the y-axis.
Oh, that makes sense.
So this one, what was it? A bit of it was reflected in the x-axis. The negative bit is reflected in the x-axis. This one is reflected in the y-axis. This one is x-axis, but not the entire thing now, but I'm sure you'll remember it. Not the entire thing. You can always test points. If you're not entirely sure, just do what we did. If you're asked to sketch something in an exam, you can get crossing points and you can get your later on with your max and min and stuff. But yeah, you have the ability just to sub in any point and then get it. So if the absolute value is just around the x, it'll be reflected in the y-axis. If it's the whole thing, it'll never drop below the x-axis. So any bit that is below the x-axis will get reflected in it, which you already knew. Okay. Let's look at section 1. I'm going to take one of the questions from the book, and you don't need to look it up, but I'll write it here. It's going to be, if you're watching the video later, it's question 7 on page 1. So we're going to bring a square root into this. Get rid of this. We remember it all. Okay, so it says our function is the square root of 4 minus x. And it asks to draw the graph of fx and of f modulus x. Okay. I'm going to do just to, I'm not going to predict where it's going to go yet. And I think it asks for yes, does. The domain and range of each. All right, so we need to get that. All right, let's draw it first, and then figure out the domain and range. So let's just do it as it is. Talk to me about some points I can put on this for sure.
X equals 0, y is 2.
When x is 0, y is 2, yeah? X is 0, y 2. Okay, so it goes through here. So that's 1, that's 2, sweet. Anything else? Is that it? What about, is there any sort of value that x wouldn't be? X wouldn't be 4?
X wouldn't be.
Well, that's actually a valid. What's 4? What's special about 4? And x. So that's an intercept, isn't it? So 4, 0. 1, 2, 3. Let's put it here. So it goes through that point anyway. 4. What happens when x is 5? It's no, yeah, it's no longer on our coordinate plane, is it? It's now we start to go into a third-dimensional complex plane. So in this case, can't graph it. So it stops here, doesn't it? Yeah. That's the last value. It can be going that way. What about going this way? It obviously goes from here. Not obviously. I think it goes from here to. Can it go further this way?
Yeah.
So let's put in a negative x. So maybe let's just do -5 and see if it work out. Yeah. So it's going to give 3 when it's -5. So it's not increasing overly fast. So it's like
increasing forever, but not fast.
Yeah, it's pretty slow. Yeah, it's not a great diagram, but you see it's pretty slow. Make that
Looks a bit like a logarithmic function,
like a sideways quadratic.
A little bit, yeah.
because it is.
Oh, that's not true. This is 2. Okay, so you can see. All right. That wasn't too bad, but we do need to find the domain and range of it.
The range is 0 to infinity. The domain is -infinity to 4.
So you're saying the range is y is
negative, or y of the range, it's 0 all the way up to infinity.
so y is greater or equal to 0, like that? Yeah, so y will be greater, but will be less than 0, yeah. The domain?
Y of x is
less than or equal to 4. Spot on. Okay, let's talk about its range. What's it going to look like?
something's gonna happen.
Can't go here.
So x naught cannot be greater than 4 because a value that's greater than 4 will result in a negative.
Yeah, it'd be a complex number. Yeah. This is not a complex plane.
I'm gonna go back down and kind of do like a weird function, I guess, again. Because when it's -4, then you can get your 0 again, put on that side.
Okay, so if we were to sub in -4 here, that would automatically turn to +4 because it's absolute value of x. So that's going to mean this is a point on it as well. This is still a point on it. Is our middle ground here? I know the scaling is a bit off, but is this on it?
Okay.
That'll still be on it, won't it? Yeah. So what is it?
And it's like a reflection of the y-axis.
It's a reflection of the y-axis. Again, same as.
If you do
What does it go on?
No, it's in this complex.
And once again, you still can't get a negative. So what's the domain and range of the blue one? So f x domain and range.
Domain x is greater than -4 and less than
X is between
-4 and 5.
f and the range values we get out.
0.
Okay, so that was one of the tricky ones that's in the book, and you can try the rest yourselves and come back to me if you have any issues. Another tricky one in the book was trying to rewrite a function with a modulus in it without a modulus. We'll look at that in a second. So you're taking a couple of notes, and I'll get rid of this off the board. Once again, I'm going to take one of the questions from the book. I'm going to 12 page. I think it's on the same page. All right. So 12 page gives us a this function. Y is equal to modulus of x minus the modulus of x minus 1. And the question is to write this as a function no longer having the modulus in it, so just a normal, normally written function with no modulus in it. That's going to be tricky, perhaps, to visualize. Maybe not, maybe it is, but looking at it initially myself, I'm trying to think, well, what does that even look like? So if you're trying to think, what is it going to even look like? Well, what would you do, Justin? Yeah, let's have a little look at values and see what it looks like. So if you sub in 1, you get a what? 1. Because, well, 1 minus 1 is 0, and 1 take away. Okay, so we know 1, 1 is definitely, so there's 1. 1, 1 is definitely on this graph. 0 is always a good one to look at, isn't it?
Yeah. 0 minus 1, so it's also 1.
No.
0 minus 1.
Yeah, so 0, so it'd be 0 minus 1. This minus 1 goes to positive 1, but that minus is still applicable. So it'd be 0 minus 1. That's positive 1, so it's actually minus 1, so you have to be careful of that. So it's 0 and minus 1. That's down here, so it's 1. So this is also on it. Okay, it looks like a diagonal. That's yeah.
It's not the absolute value, 0 minus 1.
It's not the absolute value, it's not the whole thing absolute value now, because this negative is going to affect this.
So if it was a negative, that means it would be positive.
If it's inside the thing, yeah. But this negative is not inside the brackets. There's the brackets, and there's the inside brackets. So that negative, so the total of this was 10, the total of this was 11, it'd be 10 take away 11. So you could get a negative answer. And that's interesting.
Negative 1, negative 1, negative 2, negative 1,
2.
1 minus 2, negative 1.
Okay, so you're testing negative 1, is it? So negative, that's negative 2, negative 1, so that's 1 minus 2, which is minus 1. Okay, so minus 1. So the flat line here, does that flat line continue? Well, let's try 100. Negative 100 minus negative 100 minus 1. That's positive 100 minus 10 so that's minus 1. So it does continue. It is a straight line. Okay, obviously the video caught that, if you're going to catch that there. So every other point is just going to be the same thing. It's going to go through that same system of subtracting 1 more than that. All right, so we've got a straight line to here. Obviously, it goes some diagonal to here. What happens after that? Does it continue off shooting? Does it straight line? Does it come back down? How does it go? Do 100 again.
Yeah. Oh, it's not straight line.
It's going to be another one, isn't it? It's going to be 100 to take away 99. So that's the straight line here. So I in my head, I did 100, take away 100, take away 1. That's 100 minus 99. It's still minus. And, okay, so that's 1 still. It was at 1 and it continues at 1.
Then if you just go off of what we already know, then it's just reflected over the y-axis.
All right, what's the question again? Question is, write this as a function without absolute value. How can we do that? It's not a function like anything we've seen before. But parts of it are. Here's easy. What's that function?
Well, it's just y equals -1.
Yeah.
Y equals -1. Okay. What's this function then? Say y equals -1. Say y equals 1. What's here? So we've done the straight lines. What's that then?
Y equals x.
No.
Oh, sorry, wait.
2x. That's it. What's its intercept?
Sorry.
No, it's uphill.
Oh, sorry.
So positive slope.
Intercept is that.
Intercept is -1.
Yeah. Yeah. But
So what's the equation of a line with slope over 1 up to? So y is equal to 2x minus 1 from coordinate geometry in year 11. Intercept is -1. Slope is rise over run. So rise is 2, run is 1. So that's slope. So how do I write that? That's 3 functions we know, but they have different domains. Okay? For between certain values. How do I write that? That's called a piecewise function. Did you do that in GCSE maths? I think so, maybe.
So
Pieces,
piecewise means you have 3 functions.
which is more than 1. More than 1 with restricted domains. This happens a lot in probability. Where between, so in, we'll do this later on. We won't do it until next year, but a probability density function, where probability just matches a function. But it doesn't always match an easy one function. You have to like combine some functions together. Between here and here, it follows this, and then it switches after this point. And
you just write down these 3
so your y is equal to 3 things. It's equal to 1, 2x minus 1, and -1. And then give its domain afterwards. So the domain for, well, let's do this one first. What's the domain here? When x is
greater than 1.
Okay, we'll talk about that in a second. Between here and here, so that's between 0 and 1. Yeah, 0, 1.
Equal to as well.
Is it equal to as well?
I've heard that you can do it.
Yeah.
All of them are just the 2x minus 1.
Well, let's put in the last one. I'm going to leave them all as just greater than and less than. And this is then when x is less than, what, 0?
Yeah.
When x is 0. Okay, so do I put in equal to, greater than or equal to? Or do I put in just greater than like I've done?
You need equal to, but I guess if I were to put it, you can put it in the middle of the 2x minus 1, 0, equal to, and less than 10.
Like that?
That'll be fine. Or you can get rid of those two with the 2.
Well, I suppose, yeah. What would you put in? If x was 1, if I put it into this one, what do I get out? 2 take away 1, which is 1. And same for this one. It works for both, doesn't it? Okay? So it's like a crossing. You could do that technically, I suppose, as well, either. Yeah. Okay, so there is no. Sometimes in the piecewise functions, you would get a gap. Where x doesn't equal anything. Yeah, right, x is not equal 1, and there's a circle, as I spoke briefly about. It can be a break in a weird looking equation, but we'll do that later. For the moment, that's definitely as hard as it will get. The ones in the book, that was the last one, so the ones in the book are going to be easier than that. Just sketch it, and then you might need to break it up. Usually it's 2, so usually what happens with an absolute value, it just bounces. So what would this be? This would be just 2 lines with 2 different slopes. So this might be y is equal to minus 3x plus, well, it won't be plus 1, but you get the idea. And this would be then 3x minus 3x, like minus 5, and then it would bounce off, and it would have the opposite slope going in the other direction. We'll go through plus 5. Possibly. If it bounces, would it be symmetrical? If it wasn't going to bounce, it was going to hit 5. So if it does bounce, it should. You can look at those yourself and see. But that was a difficult. Okay. Solving some equations then is next. So solving modulus equations. So there are examples, more examples in the book. I didn't use any of those. I just took questions from the book. So this is, let's just talk about in general. Okay. How to solve that?
We just solved it.
Yeah, I just want the answer.
Oh, well, X is
2. Carry in. Is this it?
What's that mean negative 2? Sorry.
Negative 2?
Yeah.
How could it be negative 2? It's absolute bracket.
Negative 5 times negative 2 is 11. Right? Then it's, oh.
Yeah?
Yeah.
No?
14 fifths.
14 fifths. If there's no absolute value brackets here, you wouldn't even be, you wouldn't be stumped for a second. It's minus 5x 10, but I said x is negative 2. Yeah? And then you doubted yourself, does it work if I sub in negative 2? 2 minus 5 times negative 2, absolute value. That's going to be plus 10, so that's 12. The absolute value of 12 is 12.
So it doesn't work.
So 2 works, yeah.
14 fifths.
So what's the problem? Will there be 2 answers?
14 fifths.
14 fifths works as well, you say?
Yeah, because 5 times 14 fifths is negative 14.
Yeah.
Minus 14 is negative 12. Times the value of that is 12.
Okay, so Ryan just got 14 fifths in his head, so yeah. So that'll be negative 12. Here in the absolute value of negative 12 is 12. Why does that have 2 answers? 14 fifths is the other answer. Why does that have 2? In the equation, 2 different answers.
Because you can get negative 12 or 12.
Yeah, but yeah, if you think back to the graph of it, if it bounces off, if I sub in x to be whatever number this is, I might get this answer, let's say it's 10. And if I sub it in again, I'll get a second answer where it's going to be 10 again, because it bounces off, it repeats. It's not like a line, and this is not a line. It's 2 lines after it hits off. So that's why there's 2 answers. So the way you would do it, yes, you take one as plus, and the other time is going to be when the answer is negative. So it can be either or. You cross the 2 points. So you take one as negative and one as plus. And if you did this out, you'd get, as Rigel said, 14 over 5. So there's 2 answers for this reason to an absolute value. So it bounces off, and there's two times y goes through 10. So there's 2 times this one goes through 12. Okay. What about this?
That's not possible.
Yeah. It's any value, well,
It's just not
the answer will always be positive. So whatever value you put for x will be positive.
Yeah.
So, no matter what we input.
Yeah. So there's no solution to that. So if you ever get that, it might be a trick question. I think it comes up once or twice in those questions in the book. There's no solution. Yeah. Because if you try to solve it, you get these 2 answers. And of course, I'm using 10 again just to show this. It doesn't, never goes down there. So how could it be in there? Okay. Let's do one more of these modulus ones before we move on to those beauties. I wonder if you use up so many books. Note taking. King over here. All right. Talk about this. This one is also taken from the book, page 163, if you're rewatching the video, question 2F. So 1/3 the absolute value of 2x plus 5 better than the absolute value of 4. This is more likely to be coming up in a sort of exam. Looks more complicated.
Well, we can start with maybe 1 for x.
You can go trial and error if you want, yeah. How many answers are you expecting?
Oh, they really asked for values of x will that be greater than, because I can already tell it's already what there is. Yeah.
Good.
No,
I start off by asking the question, how many answers are we going to get?
right?
How many answers are we going to get? Infinite? Well, you're on. So it's going to be there's going to be a range. You're going to get a selection. Exactly. Yeah. So it's not. Yeah. So it's not going to be just one value of x because it's an inequality. So we're going to get between somewhere and somewhere.
Well, it's not like
One word.
or where it equals each other and then figure out where.
Yes. How do we do that? Do you want to try? You do your way, and I'll start in about 20 seconds. Try some solution. Try trial and error. Try whatever you want. Try graphing. Try something.
Not calculated, right?
This would be a non-calculator. If you had a calculator, you could just graph to it.
Yeah.
Everything past that? Possibly. Remember, yes, third is this one, yeah? Yeah. It's not true. You may have found part of it. X less than 2?
2 works. Wait, 0 doesn't work.
0 doesn't work.
1 does though.
Okay. One makes this bigger than this.
Yes.
Well, 7. 1 is what? 7 over 3 and 3. 7 over 3 is not bigger than 3. 1 doesn't work either.
Sorry, I multiplied it. It would be 7 over, yeah, 7. 4, 9, 3, 3.
Yeah, so 2 does work.
Okay.
4, that's 0.
Yeah, no, 1 doesn't work.
0 is. 4 does work.
You said 2 works?
Yeah. So we didn't.
2 times 2 is 4.
100 works though. Maybe it's not 7.
Stop this at 100.
100 doesn't work?
4 minus.
No, it doesn't. Because 4 minus 100 is going to be minus 96. Minus 96 becomes positive 96, which takes over from this. because you have to end up getting a third of this. I don't know what that is, 200. 205 divided by 3 is less than 96 anyway, so you're right. 100, so at some stage it switches. You know it goes plus, and then in the middle it's minus if you want plus, or greater than less than. It kind of makes that thing. What makes that kind of shape? Yeah. Exactly. So the range of values of this form a parabola. How do we form that parabola? What will definitely get rid of the modulus brackets? What will definitely get rid of it? Do you know when you, in the previous example, I can't remember the question was, but it was something equals 12 or something like that. If I had done this, what would have happened? Okay, well, I got 4x squared plus 20x plus 25 equals 144. Well, what will this give us? The end of this is going to give us 2 answers anyway, I know that. Yeah? What did we get the last time when we worked it out? I know that's not the same equation, I can't remember what it was. We got 14 over 5 and we got whatever it was, 2, I can't remember. But we got 2 answers, 2 roots.
Well, this one give you like 4 roots or something? If there's 2 sets of absolute values that can be.
No. If I square both sides of this, I'm going to get an x squared here and an x squared here. If I combine them on one side, the range, the values, the answers to this form a quadratic. In other words, when we sub in values, it forms and switches because of the moduluses.
Wait, so where did the 130 go?
This is not the question. What I'm saying is, in the previous example, I can't remember what it was. You can test out later at home. In the previous example, if I squared both sides, I would get the same answers, like the plus minus. You know, when you square root, you get plus. You're always writing plus minus, but it could be either. So if I did this instead, it gets rid of the modulus brackets. If you're watching that in video, they weren't the answers. So square both sides. 1/9, that's squared. Thank you. All right, we'll do that. 4x squared plus 20x plus 25. We just did it over there a second ago. Greater or less than 16 minus 8x plus x squared. Okay. I'm going to multiply by 9 this side. Is that going to keep everything's in order if I do that? I'm not breaking any inequality rules. 9 times that is 90 and 54. 144 minus 72x is 9x squared. Let's combine my terms on one side or the other. Let's go this side. It's just nice. So I get minus 5x squared plus 92x minus 119 or something. 119. Okay. All right. So this is showing me already this, isn't it? So therefore, we're going to get a range of values where this is greater than 0 between here and here if we solve it. Yeah. Or we can flip it, change all the signs. We get 5x squared minus 92x plus 119, but you have to change the sign here as well. And it'll be the same thing. This flip fraction is the range of values between here and here. You're going to get the same answers either way. So this is, you could use quadratic formula already. Oh no, it's actually factorizable, isn't it? 7, I've done it here. If you didn't have, I would have probably gone 17 and 7 works. But if you didn't know it, you could have just used the quadratic formula to solve this. So I switched it when I did it, because I have the minus here, it's just a mess. You're trying to solve it. If you want to use quadratic formula, just go straight from here. You cool, Dustin? I just got the perfect. Very exciting. It didn't work last week. cool down, warm up for a second. Okay, so what's my answer? So x is 7/5 and x is 17. So we have 7/5 here and we have 17 here. Which one did I use? I used the U shape in the end. So I need to know, so it's between here and here, one is less than the other. Okay? So, what's my answer? X is between 7/5 and 17. Does that make sense? It would have a range of values if we were to plot two absolute value linear equations? Well, kind of, yeah. They're just going to be two V's that are not on top of each other. Actually, yeah. So in some parts they are between two values. One is going to be less than the other, and after that, it's just going to continue on.
Is that a place where they cross? And does that end up being vertex of the parabola?
This place where they cross?
Yeah.
What do you think? It's definitely a place where it changes. So it wouldn't be a vertex. Would it be a root or a vertex?
Vertex.
I would be a vertex and a root. I think it would be both. Yeah, but it does though. I think it's both.
Yeah.
You're talking about the x-intercepts, right, sir?
I'm talking about. Oh well, I just drew a sketch here. This is not these two. Perfectly done. What we're trying to figure out, what's this? When we do all this, is that if I drew this parabola, is that there, or is that one of these two, or is that just nothing? It's just.
Oh, it would be a vertex of the second.
This one is above this one. Blue one is above black one. Until this point.
Yeah.
And then black one is above blue one. Until that point. So until that point. Is it the vertex?
Yeah.
Or is it?
Well, there's not another cross, so it doesn't seem like it can be.
It doesn't seem like it's going to be the vertex.
Yeah.
Okay. So the key to solving if there's absolute values on both sides and you don't have a calculator, what would you do if you had a calculator?
Just graph it.
You just graph it. Just graph the two, and where's one bigger than the other? It'll cross at 2 points probably. This one would have crossed at 2 points. That one would have crossed.
So what does that graph have to do?
That was just this graph has nothing to do with. It's just a general sketch of what would happen. You're convinced it's the vertex.
Really convinced.
I'm not convinced. I'm trying to figure it out. I don't think it is. I still think it's going to be D. It's going to be the roots of this function.
But there's only one. There's only one intercept.
In my sketch, yeah.
But where else would it?
I know. I'm trying to think.
Because it's going to be symmetrical no matter what.
Yeah. Yeah. So the vertex. Well, minus B over A would be that one would be. Right. I'm interested in the drawing. It's just.
I feel like if it did hit in another spot, it'd be like.
It couldn't though, could it? Unless one was See, I drew them so they both came in the same direction. This one has a negative x.
Yeah.
No, that wouldn't work either. No. Probably right. That's not oh. Where is my What is it? 4 minus 6. Okay, 4 minus 6, that looks like that. Cool. Y.
Oh, maybe you're right. So if you just take that point with the cross, and you square it, it's going to be something else.
Yeah, I think crosses twice. Close. So my prediction, this crossing point is going to be at 7.5. No. Oh, we done
I
right.
just put it 7.5.
Oh, sorry, I've done minus. This is, yeah, 7.5.
Yeah.
This one up here.
Yeah.
And the range of values then changes. So this all below this bit below that, that's the values that are below.
So if it is like the sketch that you did on the board, it'd be a repeating loop.
Yeah, they have to have the same slope.
Yes, it'd be a repeating loop.
Yeah,
Yeah,
they're
it's the same exact thing squared.
Yeah, yeah. So let's put in our function that we got and see how it looks compared to so our answer function, the function that gives us our answers when it's below. So 5x squared.
So you did put 5.
Oh, it's 5. Minus 22 x plus. Now,
Where's the yeah. So right there.
the vertex.
Oh, is there any significance with that?
I don't think it is.
Just, I guess, the middle of the
It's
two.
it's the midpoint between the two, and it's the y value that that would give. And I don't think it gives any, I don't think it's some. No, it wouldn't have any significance. I don't think so. So yeah, it's just halfway point. And you see the way it also goes through. Anyway, at that point it's switched. Below that, my sketch was a little bit off. Gives a lot down. Okay, that's not. Well, that's interesting. It's good to think about things. I hadn't thought about that.
Wait, so you did, so basically you combine the two, like the inequalities to make a quadratic and the x intercept, right?
Yeah. Exactly. All right. Is this nice? Hopefully. Yes, rational functions and asymptotes. Our favorites. Okay, so let's have a look through what I've got here. Let's turn the camera. Get the board. Okay. Right, so what we know from rational functions is another way. Right, so that's what that first one I'm going to plot.
Well, -1.
-1, horizontal asymptote.
1.
1. Okay, and should have some kind of double technique. And then prediction. Yeah, the asymptotes aren't on this, but you can think they're right. And -1 here, just across, and 1, it's going towards. Next one, then, what happens if, so what I've done with the next one, you may see this, I've just included this, multiply the denominator just by another linear. How does that affect the whole proceeding? Predictions?
It'll change the both asymptotes.
Change the both asymptotes, okay? Are you sure?
Oh wait, maybe not the bottom, don't be like horizontal is like x divided by x squared.
It's like 2 answers for the vertical asymptote now, so yeah.
There's 2 times that will get 0 in the denominator. If x was 1, you'll still get 0, or -1, sorry, you still get 0, because that'd be 0 times whatever that is. And if x is 2,
There's two vertical asymptotes.
There's now two vertical asymptotes.
I think horizontal asymptote changes, and there's no simple way to figure that out.
Well, let's see. So, x equals minus 1 is still 1, x equals 2 is 1. There is a graph between the two, which is this upside down quadratic. Like green. And then is our horizontal asymptote.
Yeah. Well, it's a gap, it looks like.
It's a big one.
From 0 to something, there's
Is this going below the 0 or is it staying above?
staying right above or on it.
Oh, it looks like it's below.
It is going above. They're going crazy slow. I don't know.
It dips a little bit down.
If you look up from the point of the quadratic, you can tell what the asymptote is.
So this is where we need to examine the definition of asymptote.
Horizontal asymptote.
As the line, or the graph, right, goes towards infinity in both directions, or any direction, it tends towards a number. The distance between it and the number gets closer and closer and closer. So eventually we say there's insignificant distance, but it doesn't quite reach it. It's an asymptote nearly a second. What does this tend towards going both ways?
The value that's between.
Horizontal. This vertically kind of we look at it. It's going. This one's going towards 2, and this one's going close to minus 1.
Towards that graphical thing.
It's not actually. It's just 0. It's just 0. It never gets any distance away from 0.
With the horizontal asymptote?
Yeah.
I thought you just said it was below. It went below x. X-axis.
Just slightly below. But what's it tending towards? It's tending towards 0 from the negative side. Yeah. Crosses it and tends towards. So the definition of an asymptote. It's not a line that would never cross. Usually up until now, it's regarded as a line that would never cross ever. No. An asymptote is a line that approaches going towards infinity. So when we get to the more complicated functions, lose the thought of it never crosses. And it is now where it tends towards, so you expect asymptotes going in every direction. So as it tends towards infinity, how do you test if it tends towards infinity? You plug in a huge number and see what you get. What usually happens is, when we look at this in a minute, what usually happens is if you get 1 over a very large fraction, it's tending towards 0, and then that fraction is going to get larger and larger and larger. In this case, that fraction will get larger and larger and larger. Yeah, because the denominator is bigger than the numerator. It's definitely going to be bigger. Now, for a time, it's below 0, but it's still going, fractions going to get closer and closer to 0. Okay, so bearing that in mind, tell me where this would have vertical asymptotes first. Amazing. Yes. So if you solve this out equal to 0, you get negative 5, negative 2. What about the horizontal asymptote? Think about this gets really, as x gets really large and really small. Okay, but x gets really large.
Yeah.
For the horizontal asymptote?
Yeah. First asymptote we got as 5 and 2, the solid and long.
X gets really hard, it's going to be really small.
Well, a very small fraction. Either way, negative or positive, it's going to be a tiny fraction, yeah?
X gets really small.
So it's going to, because it's x, it's negative to the huge x, it's still going to be squared down here. And I approach it from underneath here, but it's going to be tending towards 0 as well, isn't it? But maybe from the negative fraction. What about as it goes this way, towards negative infinity?
It won't kill it. Does it? Oh, yeah.
So as we said, it'll dip below here and then come back up.
No, so it doesn't look below.
It doesn't dip below, that's a negative x on top. So it's still a negative infinity positive number on top. So it'll be a positive fraction, yeah? And x squared is going to be positive as well.
Still tending to 0.
It's still tending to 0, but from the other side.
What do you mean if the x is negative on the numerator? That means like every negative value you put in fraction will be positive, right?
Yeah, exactly. Any positive value will be negative. That's why here this fraction is very close from underneath. But it still tends towards the asymptote from both sides, although crossing it here and here, it's tending back towards it from almost opposite sides. It's not that negative x. So the asymptote of this, the horizontal asymptote, there is 1, and it is what?
0.
Y is 0, yes. So for all of these types, if the denominators higher degree than the numerator, you can pretty much say that
At the 0 eventually.
that this, I'm just going to say, I'm going to be careful. For a quadratic and a linear, it does get more complicated. We'll look at those in a second. So I'll write down the board what you can always say. Here, just in case you get it wrong. What you can always say, if you have, so I'm talking about degrees. So in other words, x squared is a degree. So if the top degree is smaller than the bottom degree, which is the example we have here, then the horizontal asymptote is y equals 0. If the top degree is equal to the bottom degree, then it's the ratio of the coefficients. So if it's 2 over 1 or it's 3x over 3, or 3, right? Yes. So so if we had the rational function 3x plus 1 over x plus 2, whatever, you just it's 3 over 1. Yeah. So if they're equal, you just do the ratio of the coefficients. Now what we want to look at is if the top is greater than the bottom. Now think about this before we get there. Think about it. The top is greater than the bottom. We look at one person. Okay, we did that. Sorry, I just want to go through these before we get to that. This one is a complex. The bottom of this is going to be complex group. What do we expect to happen? Correct. But there's no, what we did, it's also tending towards 0 this way. Horizontal asymptotes, that follows the rules we're writing here. But it has no vertical asymptotes. Because at the bottom will never equal 0 because it would be negative square roots. It has no real roots, so it has no vertical asymptotes. If it only has complex roots, no vertical, that's interesting, isn't it? So it has no blocking points. What about the next one? So this is factorized as x minus 3 squared. This one is x minus 3 squared.
Yeah.
So how many?
It'd just be 1 for
You're expecting one asymptote. You're right. Just one asymptote. Once again, these are tending towards horizontal 0 asymptote, right? 0. Now the next one. This is what I'm talking about. Doesn't have a vertical asymptote, so moving on. This one is the one we're looking at. Does each have a vertical asymptote?
Yes.
Negative 1, probably. Do you think it's going to have a horizontal asymptote? Negative 2? Was it negative 2? You said negative 2? What? So to have the horizontal asymptote, Yeah.
And move the x plus 1 to the y.
The horizontal.
That's one way of doing it, yeah, and then solve it, yeah.
And then you can just swap it with there. So you get two x's.
No, that's not what, no. You're trying to think of a barrier that is saying, may go towards, but never cross. Is it, like, that's 10, let's make x huge. Is x, when it's big, just going to be bigger, bigger, bigger? Is there nothing won't cross for any reason? Hello, negative x.
Negative x. Really large negative double also. I'm giving negative.
That's not a look.
Oh,
So this is easy to any horizontal asymptotes, right? Not like last time. There's no barrier. It's going to fly off, fly off, fly off. Instead,
it doesn't have.
it does seem to do some kind of asymptote.
It's not very
It's not
fun. No, very fun.
Is there a asymptote here?
Wait, sorry.
Yeah, but it's really negative. It is approaching negative one.
But is there a vertical?
But there is another asymptote.
Okay. Some diagonal.
It's a diagonal. Called it oblique asymptote. And we have to find it.
Oh, okay.
Okay, I'm going to do one to find it. I'm going to do this one down here. Okay, and then I'm going to graph it. I'm going to graph it without getting lost, and then we'll see if I'm right on this. I know I'm right, but check it of course. But, okay, let's have a look. So, the one we're looking at is down anyway. It's 2x squared minus x plus 1. I basically want to try to graph this. I'm graphing all the asymptotes it has. Okay, my start is pretty easy. Okay, all asymptotes. Can't remember if that's the way the question's asked, but it's asked something like that. All right. Vertical asymptote isn't a problem. Easy. Okay. How do I find a diagonal? Oblique asymptote.
Please spell that, sir. ABLOCK.
Let's spell it right for you. Oh, no, it's a Q. OBLIQUE.
Oh, okay.
I just put OB on my thing, so I'm trying to. I think it's QUE. You can check it in the book anyway.
Yeah, I think it's right.
Think it's right? Vision is going to give you
Yes, that's what I was thinking. Divide it, maybe you get to do the remainder. If it is over
All right, let's have a look. So x minus 2, let's see what happens. 2x squared minus x plus 1. Let's divide it in. So 2x, we don't know this works for certain, but we're going to try and see what happens. 2x squared minus 2x here, or 4x squared minus 4x. Subtract that then. So I get 3x plus 1. I am going to have a remainder. Plus 3 is here. And I have 3x minus 6. And I subtract those, and I'm going to get 7 as my remainder. So using what we know from the remainder theorem and quotients and all that, this can be rewritten.
That is x S2 times 2 x plus 3 plus 7 divided by x minus
Can we write it as that what you're saying? Minus.
Yeah, just add 7 divided by what you can divide it by.
What's it anyway? 2x.
X minus 2.
Okay. What is the doubles?
Put the remainder on top of the original denominator.
The remainder on top of the original denominator. Yes. Yeah. X minus 2 fits into this.
Right.
2x plus 3 times, we've got a remainder of 7 divided by it still. Like a bit like a fraction.
That means 2x plus 3 is a factor of that, right? With the remainder of 7.
Well, that's not a factor then. If it was a factor of it, we could factorize. At the moment, we can't factorize that. That's not going to give us that factorized.
Oh, yeah.
Okay.
I want to say something.
Can I use the bathroom?
Yeah, sure.
That was the one.
Why is that 10?
Well, oh yeah, because you factor it out, so then technically it's just 1 over 1, sort of. So then you just get that line left with the little additional bit. So then it should. It is.
This is the line it tends towards.
Yeah.
The line that does not cross. No, I left up the old one. I have, yeah.
But I can see it though. It goes over sometimes there as well.
Yeah, it's going to. With the old one, the one we have on the board, the function must have been x squared, was it plus 3x minus 10? And that would have been divided by x plus 1, so we divide that in, that becomes x squared plus x, subtract, and we're left with 2x minus 10, divided again, plus 2, so we have 2x plus 2 minus, so minus 12 here is our remainder, so it's x plus 2, and then minus 12 over x plus 1. Okay.
So are you dividing like 2x?
And I did a different question.
One on the board.
To the one that's already pre-graphed on the board. So x plus 2, we have said, a second ago, well I have said, is your asymptote, but this one tends towards. So x plus 2, we will put through as, okay, that's a 20, so that's here, and then we'll have a slope of 1. So yeah, that makes sense. So it's going for every box that goes over it goes. So that's that. It doesn't tend towards that. Why does it never quite get to? It gets close. I say it gets. This fraction determines how close it gets. Or sorry, this fraction determines how close this one gets. It gets huge, but so does the asymptote. Also gets huge when you sum towards infinity. It also gets huge. The product will be huge, but it won't quite make it. Will it?
They have the extra remainder.
Because we got a remainder here, we'll never quite make it to that point. Because as the asymptote goes, gets bigger, the product gets bigger, but then it is just short of it because we got a little fraction here to take away because there is a remainder. Maybe not technically mathematically correct what I said, but that's the idea. The product will tend towards infinity, the asymptote line will tend towards infinity, but the product will never quite cross that, get past the
remainder is how much, how close it will get. That's what we said. So you'll eventually get just to the exact same line parallel.
You will not get that line.
Yeah, you'll just get the parallel line directly.
No, it's
so like you're right.
Because it goes back a little bit, or add a little bit. Yeah.
What was the purpose of dividing the original denominator from there?
So I divided it to show you in both cases it works that when you divide, what does divide in, as in, I suppose you could call it a product, those two are a product, what does divide in will give you the oblique, the diagonal asymptote. So x plus 2 was the asymptote for the one that's on the board at the moment. This one, I multiplied it out to get this first, and then I divided it. This is the asymptote, and this is the asymptote of the one we have, that we're going to sketch now. Watch the sketch and then see what happens.
You got x squared plus 3x minus 10 by which quadratic?
Two linears. Oh, one quadratic.
Yeah.
Okay. So my sketch. Back to that. Vertical asymptote. That's easy. Let's go 1, 2, 3. 1, 2, 3. 1, 2, 3. This might be a bit small, but we'll see. 2x minus.
That's the oblique.
That's the oblique. I know. I'm going to put in this first. Unless you do x equals 2. Okay, so that's x equals 2. That's my vertical asymptote. My oblique asymptote now is 2x plus 3. So I know past the 3, I'll say it might be a bit small. We get there. We'll have to remove this and then put it back in. So we still need to write if top was bigger than bottom, what happens? Just for body owners. Okay, so this goes through this, and a slope of 2 for every 2. So the next point will be here. We have that, and then down somewhere there. Okay, so it's this. It's not like that. Okay, because my scale is off. All right, so these two do cross. Where does the graph sit?
Sorry?
Where does the graph go? That's just the asymptotes I draw.
Oh, it goes on either, look at it like an X on each side of the X. So it goes up the.
Is it here?
Yep.
It's here?
Yes.
And here.
Yes.
Not here.
No.
And here. No. Where's 0 lie?
Sorry.
Where does 0 lie when x is 0? 0 negative a half, isn't it? Isn't it? When x is 0, I'm just testing a point, x equals 0. So 0 negative a half, subbing in 0 is definitely on it. So 0, that's on it.
What about x plus 2? Is that also the oblique asymptote?
X plus 2.
Yeah, from where you got
That's a different question. So when you went to the bathroom, we did the one that's already graphed. We did that one. How do we get negative half? I subbed in 0. That'll be 0, that'll be 0, that'll be 1, that'll be 0, and that'll be negative 2. So 1 over negative 2. You can keep testing points if you want. So 0, no, what? Sorry, I did the other way around. 0, negative half, that's it. 0, negative half. I can test 1 if I wanted. Where's 1 going to sit for x? 2 minus 1. So 1 on x is up here, is it? I think it's, yeah. Is it negative? It's down there, is it? So that was 1.
Yeah.
So negative 2. Down here. Okay. Does it come up from here and then turn and come back down?
Yeah, it can come the other way.
Yeah. So it must come up here, turn somewhere there, come back down. Then it has. Does it sit in here then as well? I guess it has to as well. We know that it tends towards both these asymptotes. So we know it's going to go down towards that and never cross, and down towards that as well. Get close. Get close. Gets close. You can just test these points here as well. So my prediction is if x equals 3, it either sits there or sits there. And I can test the point then if x is 3, for example, 3 squared is 9, 18, 18 take away 3, 15 plus 1, 16, 16 over 1 is 16. That's clearly up in here somewhere. So it is there. I know that's not exactly.
Oh, it's crosses 0, 0, right? So,
no, it doesn't. No, don't look at that. It crosses 0 minus 1.
0 minus half.
0 minus a half, yeah. Okay, let's have a look at it. That's our sketch. This might be, looks pretty terrible, but.
Have you found your y stuff again? Or?
There it is. Now, they don't put the asymptotes in, but it is what ours kind of looks like.
Yeah. Wait, but there's also, the positive.
Yeah. All right. And yes, we can try. Last thing we're going to do. So you're going to go through all this in your spare time, all the questions. So I'm trying to do the most difficult from each section. So the last thing we're going to do is partial fractions, which you already kind of did in the one of those quizzes I gave you. Let's have a look. Question. Oh. So a question would be, write something like 7x minus 23 over x squared minus 7x plus 10. Oh, we didn't answer this. Top is bigger than bottom? The question was, does it have a horizontal asymptote? No, it has a diagonal one, oblique one. Yes. So no horizontal asymptote, it'll be oblique, like we did. That's all in the book if you want to look at it and written out properly outline or book freehand. Okay, so write this as a sum of partial fractions. This is the last thing we're going to do, and then we can get on with our lives. All right. Why do I keep thinking about the same blue pen? Okay. Just a side note. So a side note, not the actual question. If we were to add two fractions with the variables in it, how do we do it? Yeah, let me see. How would I add these?
Yeah, you get a common denominator.
What is the common denominator?
Well, there's x and y, so you can multiply x and y for both.
What is the common denominator? Just x, y?
I believe so.
What about 5 and 3?
Oh, well, okay, yeah, you get 15
yeah, 15 xy.
Yeah.
Yeah. So 15 xy. Are we happy with 10y plus 12x?
Wait, so is this related to the question or is this like an example?
No, this is just fun. It's an example. It's just this is not the question.
Yeah.
Okay. So what this question is asking is take this and go back to there. Do that. And just two factors. Now we know a quadratic can be factorized into two factors. And that's how we do this. Partial fractions, I want two separate fractions. But I want no x's up here. I just want numbers. That's partial fractions. Okay. So I got to split up. I'm just rewriting it, you don't need to. Okay, so let's factorize the denominator. Yeah. Oh. Okay. And we want that now to equal something over x minus 2 plus something over x minus 5. A bit like we were undoing the last one. Divide the top by each. Yeah, there has to be, yeah, there's a way of getting numbers for those. How do we get it? If you can get faster than me, go for it. What A and B would be. How will we get A and B? I'll give you the quick way, just because we're running out of time. Multiply both sides by something. Get rid of the denominators. Why would I multiply both sides to get rid of all denominators? The quadratic itself, yeah. Or the reciprocal of that. X minus 2 times, and I'll keep it in its factorized form. So I've multiplied both sides by its factorized form. Because I don't like these denominators, I'm going to get rid of them. That goes into that once. Now when I do it here, this divides into x minus 2, so we're left with, this is just 7x minus 23. This is a times x minus 5, because the x minus 2's cancel. And this is b times x minus 2, because the x minus 5's cancel this time. I may have said that wrong, but you get it. So we're set up with some calculations. There's no denominators anymore, it's just straightforward. Algebra's finished. So this stays the same. Multiply out my brackets. Ax minus 5a plus bx minus 2b. We had questions very similar to this when we did our coefficients that time, of polynomials. The coefficients of this side must be the same as the coefficients of this side if they equal each other. So I can split it up. The x's is 7 equals a plus b. The numbers is negative 23 is equal to minus 5a minus 2b. So I took the x's as 1, and I took the numbers, a bit like our coefficients we did with polynomials last week. There are two simultaneous equations we can solve. No, there'll be no x to the power 5 anywhere. Where do you see that? Here? Oh, that's x's. The x's. Sorry, just you write x. It's plural of x. Yeah. So you can solve that. Let's see if you get the same answer as I do. These two equations, solve them, and we're out of here.
The bottom one is numbers.
Yeah, the numbers, the constants. Sorry, yeah. So I'm going to multiply 135 is equal to 5a plus 5b is minus 2. So the second one I'm going to keep the same. I go sides by 3. Take the first equation again. And a must be